Chapter 20, Water Pollution. This chapter starts off with a little bit about the Gulf of Mexico's annual dead zone. There's going to be a couple questions on dead zones, a few questions actually on dead zones on the actual exam. So they're seasonal. Spring and summer are usually the big times just because of warm water, lots of light, and typically we're talking about the season where agriculture is happening. So you're getting a greater volume of runoff. With that runoff, you're getting an overload of nitrates, phosphates being emptied out into the Mississippi River Delta and into the Gulf of Mexico. Causes algal blooms. That algae dies, sinks to the bottom, and you have bacteria that digest it, break it down, decompose it, and use up a lot of the available dissolved oxygen in the water. So end up with lower oxygen levels, and you get fish and shellfish that can be impacted by that. In extreme cases, you're talking about fish kills, where you can get thousands of fish that swim into the dead zones, get trapped, and can't find their way out. Mississippi River Basin, largest watershed in the United States. You get a little satellite image so you can see that the sediment is natural. Those are things that naturally feed the environment. The problem is when this natural process is overloaded by human activities. All right, so pollution. Um, Primary sources: agriculture, industry, and mining. Uh, Basically, in that order. By volume, it's soil or sediment, which we'll get to a little bit later. This just defines water pollution: change in water quality that can harm organisms or make water unfit for human uses. Point sources: easy to identify, easy to monitor. A lot of legislation is based around those point sources because it's easy to track what's going on in there. Non-point is a little bit more difficult because there's such a wide range of sources. There's so many different places it comes from. It's much more difficult to watch, modify, um, keep track of. Essentially, with growing populations, it makes it even more difficult to control. The We kind of already talked about this piece, but agriculture, the big thing is fertilizers and pesticides that come in and can disrupt the cycles, specifically the nitrogen cycle. Industrial facilities, a lot of inorganic and organic chemicals. Organic can lead to bacterial action as well. Mining, it's more about the process of turning up the soil and having these waste piles that then when it rains or something like that, it creates more runoff and fills up waterways. Infectious disease, pathogens, we're talking about bacteria, viruses, protozoans, some parasitic worms, uh, kills lots of people, specifically in less developed areas because we'll get to it a little bit later, but they use the water for various purposes. A lack of really wastewater treatment facilities leads to a lot of untreated or poorly treated sewage getting into waterways. And those are some of the same waterways that people are using for their everyday purposes. In the book, you have this little table. I don't think that I specifically asked anything about these per se, to where you'd have to know this. I mean, you need to know the major pollutants. So this just gives you kind of an overview of those major pollutants and where they come from. You also need to be a little bit familiar with the things that they do, which we talk about: nitrates and phosphates, bacteria, viruses, protozoa, parasites, we just talked about. Oxygen demanding waste. Plant nutrients, well, in the review, I kind of talked about that these could kind of fit into this category, but these are wastes that directly take oxygen out of the water, meaning that bacteria digest or decompose these things. And so the oxygen is depleted directly. Plant nutrients are sort of indirect because it takes the algal bloom first, and then you get the oxygen depletion. Oil, gasoline, plastics, we talk about mainly with the ocean. Inorganic chemicals, we've talked a little bit about some of these things: acids, bases, salts, we talked about road salts. Sediment, soil silt, Land erosion, this is really the biggest by volume pollutant. Heavy metals, lead, mercury, arsenic, those can come from land, or they can actually be deposited through the air. And then thermal pollution, electric power and industrial plants, when they use water to either cool, say like a nuclear reactor, or the steam that's produced in other types of power plants, when it's released back in, those warmer temperatures can upset life. Streams and lakes. Biggest one with this is, remember the oxygen sag curve. Remember that streams and rivers are better, better fit for diluting a lot of those pollutants. They can recover more quickly because they have a constant flow. You do want to be familiar with the dissolved oxygen levels in the oxygen sag curve and kind of where the bacterial action is happening. So wherever this point source is that's releasing whether organic waste of some sort, you get increase in bacterial action. That's this decomposition zone. And this is where the oxygen really gets drawn out of the water during the process of decomposition. Septic zone is obviously the least suitable for life, lowest dissolved oxygen levels. And as the bacteria decompose that waste, oxygen levels can recover. So they can come back up and things can return to normal. More developed countries, agriculture is still the big one, but you do have inorganic, organic chemicals by industries and mines that also play a role in pollution. Less developed, I kind of already mentioned, untreated sewage is a major issue because that's going to increase E. coli numbers, that type of stuff, which obviously can be a major cause of diarrhea, upset stomach, a lot of those kind of illnesses. Lakes, the biggest thing is lakes stratify, so there's little vertical mixing. And that means that the pollutants are going to fall towards the bottom of the lake and they don't get filtered out that easily. So they're a little bit less effective at diluting those pollutants. And some lakes are worse than others depending on the depth, depending on the size. There's a lot of variables when it comes to that. All right, eutrophication. So eutrophic lakes, eutrophication is a normal process. All lakes have it. But we categorize lakes as either eutrophic or oligotrophic. Oligotrophic just has lower nutrient content, but it still needs that runoff carrying those nutrients to stimulate the algal growth, plankton growth. In a eutrophic lake, usually these are shallower, warmer, more turbid. They get more runoff into the lake, so they're considered basically a high nutrient lake. Again, these are natural, and this is what really feeds the bottom of the food chain, similar to the way that you would feed your front lawn fertilizer. Now, when you add cultural to the front of it, then you're talking about an overload of those nutrients due to human impacts. So nitrates and phosphates specifically from agriculture is the biggest problem with that. But you also have some other stuff here. Feedlots actually, per unit space, create greater amounts of runoff. So they're actually worse per unit space than, say, like row crops. So if you got a corn or a wheat field, you're using fertilizer, you're targeting those crops. Whereas a feedlot, you have a massive amount of waste that's building up. And when it rains, that type of stuff, you're getting an even bigger load of that waste per unit area. Hot weather and droughts is usually when you see most of these algal blooms. That's when you get a lot of light, a lot of warmth, so the algal level increases, which means there's more death, which means there's more bacteria, which means they're going to deplete the water of oxygen. Best method of avoiding any type of pollution is obviously to prevent it from happening in the first place. Diverting that agricultural runoff, sending it somewhere where it can be collected and maybe treated is ideal, but it's such a massive amount of space you're talking about, and so much in terms of logistics, money, infrastructure to do that it's really challenging. Cleaning up lakes once the algal bloom happens, you can see it's obviously pretty difficult. At this point, it's basically herbicides that can do the job.